Hi guys, today I'm going to talk to you about an enlargement, and in its most basic form uh, it's just about making sure each side is longer than the previously, or longer or shorter according to a multiplier. So if I said I wanted to enlarge with a scale factor of 2, that means I want to make each of the sides two times longer. So this one here is 1, 2, 3 squares long. So if I get 2 times long, I'm going to make it 6 squares long. And this one is 1, 2, 3, 4, 5, 6, 7. So I'm going to make that 14 squares long. 4, 8, 12, and another 2 in there. So there's my enlargement. And you can see that this was 7, that's 14. This is 3, and that is 6. So across all my sides, I've kept that scale factor going. And that's really the most basic aspect of it. I'm just going to do another quick example. If I was to draw a little rectangle here, and then I'm going to make a rectangle 3 times bigger, so a scale factor of 3. So where this is 2, I'm now going to make it 6, and where this is 4, I'm now going to make that 12. So 2, 4, 6, 8, 10, 12. So that's 12, and that's 6, and that's 2, and 4. And you can see that I'm timesing by the scale factor to get there. This one times is by the scale factor again. Now, but there is something a little bit more I'd like you to notice about this. I'd like you to think, well, what happens when I join the corners of this shape together? So I'm just going to pick on the ones that are relevant to each other. So that one and that one, I'm going to join them together with a line that I'm going to call a ray. And then I might join these two together. Okay. And then I might join these two together. And these two together. Sorry, these two together. Carry my ray forward. And so when you join the corners, when joining corresponding proper name for a corner is a vertex, so the plural of that is vertices. When joining corresponding vertices, they all meet at a centre of enlargement. So I drew that anywhere. So because of the position I drew that determined where my centre of enlargement was. But we can actually determine where an enlargement goes by prescribing a centre of enlargement. So if I wanted to enlarge scale factor 2 about O, remember O is the origin, I would put these rays here from the centre of enlargement to my corner of my shape, and then I'm going to carry on into space. And I'm going to do the same with this one. And I'm going to do the same with this one. So what I know is my enlarged shape will have corners or vertices on these lines. So you can see it might come here, here, and here, out there somewhere. And generally what we do is we measure the distance along these lines. Now this has to be done quite accurately, and you will need quite a sharp pencil. I've not done mine too good there, so I'm going to use a little bit of a cheating method. Right, in my cheating method, I'm going to look at how I get from O to my corner. So I'm going to this vertex here, this corner here, and I go 1, 2, 3, 4, and 1, 2, 3. Now that distance will be multiplied by whatever the scale factor is. If you look here, we've got the same distance there, there, and there. So the distance from here to here is multiplied by, that's doubled and then tripled to get the distance there, and that was related to the scale factor of 3. This one's related to the scale factor of 2. So if I've gone 4 and then 3, in order to get where I actually want to be, I want to go 8 and then 6. So that will give me the point. Actually, it's about here. And when I go to this point here, I'm going 4 along, 3, 4, 5, 6, 7, 8, 9. So if I want to go to the enlarge point, I want to go 8 along, so that's double that initial 4, and then 18 up, which should get me to about here somewhere. And then this one, I'm going, this is 8 squares along and then 3 squares up. So I want to go 16 squares along and then 6 squares up, which would be around there. And that gets me my enlargement. There and there. And if I look, if I were to measure that, that's 2 centimetres. And that's about 4 centimetres, that's right. This is 3 centimetres, and that's about 6 centimetres. And this one is 3.7 centimetres, and that one is at 7.4 centimetres. So, the traditional way to do it is to say, I'll measure this distance here. That is 4.8 centimetres, and then because I've got a scale factor of 2, I'm going to times it by 2, and I'm going to draw 9.6 centimetres along that line. So that's generally how you do it. I like to have my little cheat method by saying, if I count the squares 4 and then 3, because it's a scale factor of 2, I'm going to double that distance and go 8 and then 6, and that'll give me to where my point is then. So 2 different ways to do it. Measure the distance, double it, and that'll give you where the one in the image is. Remember, this is the object, this is the image. Or you can do it by squares 4 and 3, double that to give me 8 and 6. And again, this one was 8 and 3, so I'd be 16 and 6. Okay, hopefully that's not too confusing. I know you're used to doing it like that, but this whole idea of them joining at the centre enlargement and then using a centre enlargement to come out from there through the object to create the image, by thinking about distances that you would travel along those rays. Okay.